Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to be going over Gibbs free energy. We're going to talk about what it is. We're going to talk about how it's related to temperature and the enthalpy and entropy of a system, the changes in those things of a system. So let's get into this. First thing is let's remind ourselves the equation that the change in the enthalpy or a change in the entropy of the universe is equal to the change in the entropy of the system plus the change in the entropy of the surroundings. So let's remind ourselves that the spontaneity of a process is tied to uh, the increase in the entropy of the universe. So if the entropy of the universe increases, then that's going to be a spontaneous process. So let's also remind ourselves when we're talking about in my earlier video that the change in entropy of the surroundings is equal to the magnitude of the enthalpy of the system divided by the temperature in Kelvin. And so we remember that it's the enthalpy of the system. Remember, there's an exchange of energy of the system. So the enthalpy of the system, if it gives that energy to the surroundings or if it absorbs that from the surroundings. So it's going to be the entropy of the system, or I'm sorry, the entropy of the surroundings is tied to how much energy is absorbed or absorbed from the system or lost to the system at a particular temperature. So if we take these two equations, right, we could take entropy of surroundings here and substitute this in for this. So we get then the entropy of the universe is equal to the entropy of the system minus the enthalpy of the system divided by temperature. And so now we have the equation where you have the entropy of this universe in terms of the system here. So we can look at the system and not the surroundings, right? So then what we could do is we can multiply the equation by negative temperature. So when we do that, we get negative T delta S of the universe equal to negative T delta S of the system plus delta H of the system. So when we multiply by negative T, the negative cancels out and the T cancels out as well. So this is our equation now. So we get this here. And so what we can do is we can just drop the system and just keep in mind that when we're talking about negative T delta S and delta H, we're talking about delta S and delta H of the system. So we can drop that. So we get negative T delta S of the universe is equal to delta H minus T delta S. And keep in mind that delta H and delta S are the enthalpy and entropy of the system, and this is at constant temperature. Okay, so this is an important equation because this negative T delta S of the universe is what we call a change in Gibbs free energy. So Gibbs free energy is a thermodynamic function that is going to be a measure of the spontaneity of the reaction or a process. So this negative T delta S of the universe is the Gibbs free energy. And so I can show you that by saying, hey, this is the formal definition of Gibbs free energy is this equation right here. So Gibbs free energy is equal to the enthalpy of a system minus the temperature multiplied by the entropy of the system. So here, that's the formal definition. If we change this to the change, so if we make this the change in Gibbs free energy, so up here we have the change in Gibbs free energy is equal to the change in delta H is equal to minus T delta S at constant temperature. And so therefore, Gibbs free energy is equal to this. This here is also equal to the same thing. So that means that the negative temperature of the change in entropy of the system of the universe is equal to Gibbs free energy. So Gibbs free energy, the change thereof, the change in Gibbs free energy is equal to the negative temperature multiplied by the change in delta S of the universe at constant temperature and pressure. So what this tells us is that the change in the Gibbs free energy is proportional to the negative change in your entropy of the universe. And that's important to keep in mind because remember that the change in the entropy of the universe is what is tied to the spontaneity of reaction. It's a criterion of whether or not a process is going to be spontaneous. So remember, we want this to be positive. So we want an increase in entropy in the universe. This is proportional to the Gibbs free energy, except it's opposite in sign. So we want an increase in the entropy of the universe, which leads us to a decrease. We want a decrease in Gibbs free energy. And this is important because since the change in the universe is a criterion for spontaneity, so therefore delta G is also a criterion for spontaneity. So if we can measure the change in Gibbs free energy, then we can use that to determine whether the process is going to be spontaneous or not. And so because delta G here, or the change in Gibbs free energy is negative, right? Because we want the change in the entropy of the universe to be positive, and then the change in Gibbs free energy is the opposite sign of that. So we want that to be negative. We want that to decrease. So spontaneous systems are such that they go in a way that's going to decrease the Gibbs free energy. And why is that important? Because Gibbs free energy is also called the chemical potential because it's analogous to mechanical potential energy. So remember we talked about in our previous video, right? Things naturally fall to lower the potential energy. They go in a way to lower potential energy, right? So if I hold a book and I let go, it spontaneously falls to the ground because that's lowering the gravitational potential energy of the book, right? So in an analogous way, the Gibbs free energy is also a chemical potential. So all processes go towards lowering the Gibbs free energy or the chemical potential. So just like chemical systems lower potential energy, so also chemical systems lower the Gibbs free energy or the chemical potential. So Gibbs free energy is a way that we can measure or determine whether or not a process is going to be spontaneous or not. Okay, so in just a moment, I will summarize what we just went over, and then we're going to go over 4 different cases to see how the temperature, the enthalpy of a system, and the entropy of the system work together to either increase or decrease Gibbs free energy. All right, welcome back. So to summarize where we are, with regard to Gibbs free energy at constant temperature and pressure, we saw that delta G is proportional to the negative of the delta S of the universe, the entropy of the universe. So we want entropy of the universe to increase for a spontaneous process, which means that we want a negative change in our entropy. We want a decrease in the decrease in the Gibbs free energy. So an increase in the entropy of the universe leads to a decrease in the Gibbs free energy of the system. So, so that tells us that a decrease in Gibbs free energy, which is going to be negative, corresponds to a spontaneous process, and an increase in Gibbs free energy, which means that delta G is going to be positive, corresponds to a non-spontaneous process. And so we can see here that we can calculate the Gibbs free energy by just going to the system. So we can calculate the enthalpy change of a system. We can look at the entropy change of the system, and we can look at temperature, and we can see how all of those together come to give us a certain quantity of Gibbs free energy, and then using, or the change in Gibbs free energy. And so using that change, we can determine whether the process or the chemical reaction is going to be spontaneous or not spontaneous. So in this video, we covered Gibbs free energy. In my next video, we'll talk about and show how those factors of enthalpy and temperature and entropy of the system affect the Gibbs free energy. So I hope you enjoyed this video. I hope this was clear and helpful in some way to you. If you like this video and it was helpful, please make sure you hit that like button right there. Also, subscribe to my channel, hit that notification bell right up there so you'll be notified by other videos I put out. And also put a comment down in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me, and have a great day.